Hi folks, this is Calc 2 Quiz 4. We have a couple of integrals to handle here. We're asked to integrate sine squared x cosine squared x dx. And so we think back to our rules of thumb. Can we spare a cosine and convert everything into sines? And the answer is yes. In fact, this is a Calc 1 integral. So when I'm keeping back a cosine, I'm thinking of that as being the du, and that would be the du from a substitution u equals sine of x. So the du then is cosine x dx. And so in the land of u, this becomes u squared du. And the antiderivative u squared du is 1/3 u cubed plus c. You've solved it for you, now you got to solve it for me. I want the x's back in there. So this is 1/3 sine cubed x plus c. And that'll do it for part A. Let's look at part B now. We're integrating sine squared x dx. So we don't have that cosine in there anymore. And that's going to play all kinds of havoc because we can't keep a cosine back as part of our du. Similarly, if we took a sine back, we'd only have a sine left. And so we can't make a cosine substitution. So in this case, we have to use our double angle identities from calculus or from trigonometry. Sine squared of an angle is the same as 1 minus cosine of twice the angle over 2. And so I can factor the 1/2 out front. And we're back into a Calc 1 integral. So the integral of 1 dx is x, so times 1/2, we get x over 2. The integral of cosine 2x dx is sine 2x over 2 times that 1/2. So that's going to be sine of 2x over 4 plus the ubiquitous c. Now, if you want to check your answer by taking the derivative, you'd get your 1/2 from here. You'd get the cosine x over 2 here. So you'd have basically this identity, which then you would have to use identities to get back to the original integrand. So typically when you have trigonometric integrals, if you use identities to help you integrate it, then you're going to have to use those same identities to simplify to get to your integrand when you check your answer. And so that's going to do it for quiz 4.